Hello, everyone, and welcome to the December online viewing session of the Kalamazoo Astronomical Society. I'll be your host for the evening. My name is Richard Bell. I am also the president of the Kalamazoo Astronomical Society. And the first disclaimer I want to get out of the way here is I have been extremely sick all week long. This is the first day I felt kind of normal. I'm not quite there yet. Um, I've barely spoken this week because my throat has been so bad. So we'll see how long my throat holds out here, and maybe it'll collapse mid-session, and then I'll just mime the rest of the thing from there. We'll let all the pictures do the talking instead of me for a change. But I think I'll be okay. I got plenty of beverages. I got uh, Bricola throat lozenges, so hopefully I'll be okay. But it has been a pretty tough week for me. I spent most of it in bed, not doing much of anything. But I'm feeling good now. So let's just jump right into it. I mean, there's no reason to delay. So let's go ahead and begin here. So we got our title slide here, and of course, in the background, then we can talk about the picture here. This is the house of Mike Patton, who is joining us this evening from the observatory, but this is his house. And hiding behind this little shrub here is the actual observatory with the wondrous hills in the background there. And of course, there's the observatory itself, called Peishi Observatory, which is Apache for Nighthawk. Mike Patton wanted to keep the bird theme because, as many of you know, we have Owl Observatory here in Kalamazoo. So he figured, since the KAS telescope is in here, he wanted to call it the Nighthawk Observatory, but because of the local Apache tribe, he went with Peishi Observatory. So it's a 20 by 20 roll-off roof of observatory. And I'm trying to find my laser here. Oh, here we go. And so you can see the telescope poking up here. This, of course, is the 20-inch, and you can see the Takahashi peeping up there. But yes, it is a 20 by 20 roll-off roof observatory. And so we're kind of located in the north east corner. Yeah, northeast corner. And then there are other telescopes in there that maybe we can take a peek at later on the live camera. And we have our weather station here. And we can check the current weather here shortly. And then, of course, the other little box is a all-sky camera, which looks like this. So here is our old S-Big all-sky 340C, which means it's a color camera. It is now obsolete. They no longer make these, and we may hopefully try to upgrade this in the next year or so. That depends on the generosity of members and maybe some of the guests attending here tonight. So let's go ahead and check the current all-sky camera. So let me change my screen share here. And this screen is the ACP screen, but we're going to switch to this tab here. And here's the all-sky 340C camera right now. And this little funky contraption that catches your eye up front, if you've never joined us before, this is our bird perch that keeps birds hopefully off the dome here and leaving little droppings behind, because that has been a big problem. And then this little glowy thing here, that's actually the roof roll off. And you can see there's some neighbors to the south of us now. And Mike Patton did have a friendly conversation with the neighbor here, because those of you that joined us last month know he had this really obnoxious red light on, like pointed like right at our camera the entire night. But we've since talked to him, and he didn't realize it was a problem, even though he should have. And he will keep that off here, and I can feel my throat starting to go here. So give me just a second. Okay. So we can see a bit of the Milky Way here, where we had pretty much lost the bulk of the summer Milky Way here. But you can still see a little bit of it. Now, as we kind of go over to this side of the Milky Way, we begin to get toward the winter portion of the Milky Way, which will rise during the course of the session here. And we'll start over in the western sky here. This is where everything's going to set. And we see the summer triangle. We have Vega, Deneb, and Altair. And we will have one prominent target right near Deneb here at the start of the session. An object we've done before, but has always been a big hit. And it's been a couple of years since we've last done it. But so if you know what I'm talking about right near Deneb, then you got a sneak preview of what we're going to do later. And so the summer triangle here is the dominant asterism of summer, which is now a distant memory because we are now approaching winter. It's still technically fall, but it feels like winter out there now. And high in the south here, way high in the south, basically at the zenith from Arizona Sky Village, the home of the remote telescope, we have the Great Square of Pegasus. So the Great Square is made up of two different constellations. We have Pegasus here. This is the back of the horse. And then there's kind of like a little triangle here for the head. And this star here is called Enif. And if you joined us last month, we did M15, which is right about there. But we're going to do a different globular cluster this month. We're not going to do M15 again. And we have one leg kind of going off here and another leg going off here. And so that's the horse flying upside down. And then we have Alpheratz, which is the head of Andromeda, which is basically two arcs of stars that meet at Alpheratz. And this mighty object here, this brilliant object here is Jupiter. Saturn's like over here somewhere. And it doesn't look too dramatic here on the all-sky camera, but Jupiter does. And of course, we'll do some objects around this area here. There's a prominent cluster here that we're going to do that we've never done before. And there's a nice galaxy over here that we're going to do right near this little constellation right here, this little tiny constellation called Triangulum. And we can even see some of the winter constellations start to rise here. We can see Auriga the Charioteer. And we see the Hyades here, but you can see that stuff is still pretty low in the eastern sky here. And we're going to save that for future sessions when we get into January and especially February, when these will be much, much higher in the sky. And you can see the page just reloaded here because I have it set to reload every 4 minutes because the camera takes an image every 4 minutes or so. But of course, the camera interval and the reload interval aren't exactly synced unless you get really lucky and time it just right, which never happens. But so this will update as we go on here. And we can switch to another view here because, boy, this view is much more impressive. It looks like we even captured maybe the space station or a satellite going over. But this is the all-sky camera of one of our neighbors, David Churchill, who has a two-domed observatory. And you can see his view is a lot higher quality. So we're hoping to maybe switch to something like this in the near future. So again, you can see the summer triangle much more plainly. You can even see what we're going to take a picture of here later. And again, there's brilliant Jupiter. But kind of the one thing is we lose a lot of the sky behind the two domes there. And again, high overhead above the Great Square here, you can see the constellation Cassiopeia. So that's the current condition of the night sky. And we will switch back there from time to time during the course of the session. But as always, we're going to start with our first telescope here, which is the Takahashi FSQ 106 EDX3. Very, very nice 4-inch refractor. And if this is your first time joining us in a while, you can see the Takahashi does look different. Last year, we made an addition to the Takahashi, or a high-end replacement. We replaced the standard focuser, which could not support the weight of our mighty camera and filter wheel, with a very high-quality Moonlight Nightcrawler 2 focuser, which is just a really, really good focuser. So you can see the Takahashi rides piggyback on the camera. And why don't we go ahead and switch back? Let's switch back to the browser for just a second if I can find it. And you can see, here we go. So this is a somewhat live view of the telescope, but for some reason in Firefox here, which is what I use, the PEC cam, as we call it, freezes after like the first 30 seconds or so. It'll run for 30 seconds and then it just freezes, which is better than Edge. It used to run really well in Edge, but now with the Microsoft Edge browser, it doesn't load at all, and I really don't know why. They made some changes to the browser, and now we don't use this camera too much anymore. But it's still running, but it just doesn't load too much. So there's the Takahashi, relatively live, and of course you can see the bigger scope here as well. And we can switch to the next tab, but unfortunately, Mike Patton's mighty 7-inch refractor blocks our view of most of the Takahashi there. You can kind of see the Takahashi behind his Foscam here, and so you can see where where the telescope is in the observatory. So you can see our pier and our mount, which we'll talk about later. This little funny white thing here is our flat field for the big scope. The Takahashi has its own flat field, which you can see here. It's called a flip flap, and we use it as our remote dust cover too. So let's go to there we go. So we're going to go to the ACP here, which stands for Astronomer's Control Panel. And this is what we use to control the telescope. So all you need is a web browser and, of course, a username and password, which I'm not going to share unless you pay me $100,000, and I'll share you my username and password, and it's all yours. So any member that um, joins and uses the remote telescope, all you need is a web browser to control it, which is what I use here. And this will be our, you can see there's an image here already. This is a target I've been working on, but this will be our finale for tonight. So that's kind of a spoiler alert here. But I've already come prepared here. I've already entered in the designation of our first target and some custom coordinates because I want this to go to a specific set of coordinates so it frames it just right. And since I'm here, I'm just going to go ahead and hit acquire image on that now, and we will introduce our first target for the evening. And of course, the camera that we'll use to take the image is our SBIG STX 16803 CCD camera. CCD cameras are becoming a thing of the past. They're being very quickly replaced now by CMOS cameras, but this is still a very, very high-end camera. It has a massive, nearly 37 millimeter square chip, just big square chip. With 16.8 megapixel resolution, which seems kind of paltry by today's standards, but for astronomy, it doesn't make a huge difference what the resolution is, unless it's really, really low. And of course, we have this hooked up to a filter wheel that has 7 different filters in it. And the filter that we're going to use, if you caught that earlier, is a hydrogen alpha filter. So yes, our first target is known as NGC 7000, the North America Nebula. And it's quite often incorrectly referred to as the North American Nebula. That is the incorrect way to say it. The correct way, again, is North America Nebula. I'm as guilty as that as anybody. In fact, if you're really sharp, you'll probably see me slip up on it later. So this target was discovered by William Herschel. You're going to hear that name a lot as usual, on October 24th, 1786, or possibly even by John Herschel before 1833. But it was probably discovered by William Herschel in 1786. And it was first photographed by a gentleman named Max Wolf in 1890, who gave it its name because when you look at it, it looks like the North America continent, as you can even see in the sketch here. But the sketch was probably taken through a refractor or a Schmidt-Cassegrain because it's inverted. And that's how, this object will look in a refractor or a Schmidt-Cassegrain. Of course, in a Newtonian, it looks upside down. But here we can see Florida on kind of the left and we see Mexico and California on the right, which looks a little weird, but that's the way it looks in a telescope. And you can see it's very large. It's 120 by 100 arc minutes. For comparison, the full moon is 30 arc minutes, so it's big. So it's 4 times the moon's apparent diameter. And it is visible with binoculars and a wide field telescope, often using a UHC filter. And I've observed this many, many times with small refractors. And there is a 10th magnitude open cluster called NGC 6997 that roughly marks the location of Ohio, which is not part of the actual nebula complex. And you can see it's about 1,600 light years away. So here's roughly the part of the sky that we're looking in. And again, here we see Deneb, which is one corner of the summer triangle. In fact, here are the other corners here, Vega and Altair, and their respective constellations. And you can see we're looking just a little bit off Deneb. We can get a closer view here. So again, here's Deneb, and NGC 7000 is about 3 degrees east of Deneb, or 1 degree west of the 4th magnitude star Xi Cygni, which is this star right here. And you can see there is another object nearby called IC 5070, the Pelican Nebula. And so that's why I entered in custom coordinates, so it nicely frames the Pelican Nebula. Because again, this is not a new target for tonight. We do have 2 new targets tonight, but this is not one of them. This is one we've done at least a couple of times before, but not in a few years. So I thought it'd be good to do it again. And let's go ahead and switch back to ACP and see how we're doing. And you can see we've already acquired a guide star, and the guiding looks a little choppy. Maybe it's gotten a little windy out. We can check the current weather. Oops. And let's go ahead and do that before we open it up to any questions. Let's see here. I got to find the, oh, here we go. So the screen that I'm sharing now, this is the actual computer in the warm room at Piishi Observatory that's hooked up to the telescope. And in the upper left here, we can see the current conditions. And yeah, the wind looks pretty decent, just 3.2 miles per hour. So maybe the scene is still a little rough. But it's clear, it's calm, it's dry. Look at the humidity, 20%. That just makes me cry, considering what the humidity probably is here right now. But yeah, the conditions look really, really good out there. This must be a rough night of seeing. So let's go ahead and stop sharing. I'm going to now allow everyone the ability to unmute themselves. And we are now into our 10-minute exposure we're doing of NGC 7000. And so we probably have a good 8 minutes here to kill before we get to see the first image. So if anyone has any questions or comments, you're welcome to make those now. So welcome, everyone. And we do see the chat. Someone has an echo. Maybe they're, if you're listening on 2 devices, you're going to get a weird echo. That does happen. And yeah, we're still chucking along on the exposure there. And if you want, in the chat, you can put where you're joining us from. Of course, if you're joining us from Kalamazoo, that's pretty boring because most of us probably are. But if you're joining us from other exotic locations in the US or Canada or around the globe, we'd love to know. Okay, I'm back. I had to cut out there to hack up a lung. So it looks like we have a shy group tonight. Last month, people were chit-chatting quite a bit, but now you folks are pretty quiet. So I was hoping somebody would bail me out because of the throat issue here, but come on, folks, throw me a bone here. This session is sponsored by Ricola, which will save my life tonight. I got one left in the bag here. Now that bag's done, so I'm going to throw that one away. And I'm going to pop in another one here. I'm sorry I don't have enough to share for the entire class. So let's see. We got folks joining us from, let's see. Where's Echo? Oh, no, that's the problem people are having. Chicago, Green Bay, Sharpsburg, Maryland, southeastern Pennsylvania. Oh, and of course, Jim Broom is back from England. So it's good to have him here again, where it's probably well past midnight. Corona, California. Loveland, Colorado. Peoria, Denver. Oh, apparently I didn't. I thought I checked off allow participants to unmute themselves, but I did not properly select that. So there we go. Now people can unmute themselves. I'm sorry, I totally missed that.
You're sick. It's okay.
I could have swore I did that. I guess I missed it. Well, since no one's chatting here, let's go back to ACP. We'll just kind of watch the progression here. And
Richard,
yes.
Richard, yeah, are the Pelican and the North American Nebula sort of part of the same cloud?
They are.
Okay. So are they like the same, then they're relatively the same distance and
yeah, yep,
same age and all that sort of thing. Okay.
Yep. Basically what shapes the thing is dust, dark dust that blocks our view of specific parts of the nebula.
Oh, okay. Thanks.
Mm-hmm.
I take it the filter is all fixed?
Oh, yes. I forgot to mention that. Mike Patton did pop the filter wheel open, and it didn't seem to be loose, but once he put it back together and I tested it, it seemed fine. I ran it through its paces. And so there's no problem there. So hopefully the filter wheel will behave itself tonight. Yeah, because if you did join us last time, you know we started having issues with the Takahashi, and because it's happened to us before, not right during the session, of course, but the filter wheel on that tends to come a little loose from time to time. We've never had an issue with the other filter wheel, which is exactly the same, but go figure.
For us newbies, can you describe the differences between the Takahashi and the bigger Dobsonian in terms of its the dimensions and such? Thank you.
Sure. Yeah, again, the Takahashi, it's a 4-inch refractor, which means the lens up front is 4 inches across. And you mentioned the Dobsonian. Those are pretty much exclusively Newtonian reflectors, which can be anywhere from maybe 4.5 inches up to maybe 70 inches across, depending on some out there, because they come in a wide variety of sizes. Some can be quite large, but most aren't 70. Most are usually probably around 8 or so, 8 inches. So the other telescope, the 20-inch, has a 20-inch mirror, and that's a corrected Dahl-Kirkham, which we'll cover exactly what that means later. And of course, the big difference between the Takahashi and the plane wave that we're going to switch to later is their field of view, because the plane wave could never show us this entire nebula in one shot because it's big. I mean, it's 4 times the size of the full moon in the sky, while the field of view of the plane wave with the camera that we have, that's about the full moon, which is still pretty big. That's only because the chip is so big. And I just heard a ding in my ear. So we did finish the exposure. You can see a little preview here, but this is just a thumbnail. And hopefully the image will process a bit quicker in the background than it did last month, because the computer out there seems to be running a little on the slow side. So it should be processing the image. Oh, and I just lost the connection with the remote computer because the AnyDesk is being so strict on time here. Now you probably can't look at it yet. Nope, not yet. So while we wait for the image to process in the background there, it's still working. You can see it working here. So it's found. So
May I ask
everyone,
another question?
sure, just real quick here. Everyone go ahead and unmute yourself. And we are now going to unveil the first image of the night. So here we go. Are you ready? There we go.
Ooh, nice.
Actually, ooh.
That is very cool.
Mhm.
And of course, this view is corrected. It's not flipped. You know, this is not a mirror image, so you can correctly see the North America nebula as nature intended. So the diameter of the nebula is roughly 50 to 100 light years. And again, it's interstellar dust that helps shape the nebula. And you can see there's a really dense portion here that resembles, where Mexico and Central America is. And this is known as the Cygnus Wall. And it's very likely that Deneb is the possible source that lights the nebula, which is a star and nebula are 70 light years apart, but Deneb is a very powerful star. But another candidate could be a 6 magnitude 06 type star called HD 199579, but don't ask me where that is in this image. It's probably in there somewhere, but which one it is, I haven't a clue. And here we see the Pelican Nebula. You can kind of see he has like his mane or his top of his head here. He has an eye in his beak. So there's the Pelican. And again, the Pelican is IC 5067 and IC 5070, and they're located just southwest of the North American Nebula. And as noted, this is all part of the same nebula complex. These are not separate nebulae at separate distances. Just what makes them look separate is a little dark nebulosity dividing the two right here. And somebody had a question from earlier?
I did. I'm sorry for everybody. I'm just fairly new at this. My question is, this is a photograph over time. If we were looking at this in the dark skies of Arizona, real time with our eyes through the telescope lens, could we see it pretty well?
You could see it. Yes, you could. You could see it with a good pair of binoculars or another wide field refractor with an eyepiece instead of a camera. And what it looks like visually, though, is it looks like the sketch that I showed earlier. So maybe we can go back to that. Let's kind of go backwards here in my PowerPoint, and we'll just kind of go back to the sketch. So it'll look a lot like this. but it'll kind of have like a pearl gray color to it. Because of course you can't see any color in these objects. And of course the images that we're taking tonight are not in color because we use a monochrome camera. So to make a color image, we have to take it through red, green, blue filters, and that would take a long time to process here. We don't have the time to do that. So this is what it tends to look like, but really better. Somebody jump back ahead there. And we'll take one last peek at our target there. Not too bad. Maybe not the best image we've ever had of this target, but pretty good. And of course, the images that you can download later, you'll be able to download this image later, a higher resolution version. That'll be a little more processed and a little cleaner than what we see here. And you'll be able to zoom in to say like the Great Wall here and see more detail. So I'll work on that later, if I don't pass out after the session.
Hey, Richard, you may have mentioned it already. However, how did all that dust and gas and nebulosity come to be in the first place?
Oh, that's a hard one. Okay. Let's go ahead and bring it back while we talk about that. Okay. So basically, when stars die, they either do so as planetary nebulae or supernova remnants, and their material just expands through space, but eventually, especially in spiral galaxies, it gets caught in a spiral density wave. And so, basically gas and dust from old generations of stars will over many, many eons, we're talking maybe hundreds of thousands or millions of years, they'll collect at the fronts of spiral arms. And this density wave, as it's called, the density wave theory, because it's just one idea, is that nebulosity will collect at the front of a spiral arm where the density wave is. And gradually, this helped bring the gas and dust together to form these great nebulae that help generate new stars. And what can happen is when stars form, they have ultraviolet light, that can push the gas around even more, and that helps generate even more star formation, which is called self-sustaining star formation. So kind of the really short answer is all this gas and dust is gas and dust from previous generations of stars that died that are being recycled. Now, where it all came from in the first place, to originate from, that'd be the Big Bang, where matter was formed shortly after the Big Bang. And that really gets into a lot of territory there that we don't really have time to get into tonight. But basically, yep, all the stuff is recycled star stuff.
Thank you.
And so are you, by the way. So next time you
Correct.
look in the mirror, you can say, I am recycled star stuff.
Correct.
Because
Thank
you
you.
are. All right. Let's go to our next target, which is our new target. We've never done this before. I know this probably won't be quite as spectacular, but I figured we need to do this. So it's NGC 752. And I'm going to make sure I hit get coordinates, because if you joined us last time, I forgot to do that once, which really slowed us down. And we're just going to do 5 minutes here with the clear luminance filter. So we're basically taking a direct image with a clear filter. And we're going to go ahead and hit acquire image there. And let me introduce you to this target. So it is NGC 752, which I will call the Andromeda cluster. I mean, it's not commonly called that, but it's the most prominent cluster in Andromeda. So why not call it the Andromeda cluster? And it's also known as Caldwell 28 So it's the 28th entry in the Caldwell catalog, as assembled by Sir Patrick Moore, or Sir Patrick Moore Caldwell, but he never uses the Caldwell part of his name. And years ago, we're probably going on 20, 25 years ago, when he was still alive, he developed his own Messier type catalog. It's not, you know, really commonly used like the Messier catalog, because we'll meet some Messier targets tonight for sure. And so, you know, the Caldwell catalog has a lot of the really cool objects that Messier missed. And it's also known as Colander 23 from the Colander catalog, which is like a collection of 471 open clusters compiled by the Swedish astronomer Per Colander in 1931. So there's, you know, there's all kinds of catalogs out there, and was probably first observed sometime before 1654 by the Italian astronomer Giovanni Battista Hodierna, something like that. And but it was definitely discovered or rediscovered by Carolyn Herschel on September 29th, 1783, and cataloged by her brother William Herschel on September 21st, 1786. And it is large, 75 arc minutes, you know, again, over twice the size of the full moon. So due to its large size, it is best observed with binoculars or a wide field telescope at low powers. But I got to admit, as far as I know, I have never observed this cluster before at all. I've never even imaged it. I've never observed it. So this will be a first for me. That's kind of why I really wanted to do this one, because it's a pretty big cluster, not terribly dense, as we'll see, but it's one I need to go out and actually look at, maybe on the next clear night that we have around here. So here's its rough position in the sky. For reference, here's the Great Square in Pegasus with the star Alpheratz marking the head of Andromeda again, the two arcs of stars that mark Andromeda. And there's Triangulum, which I mentioned earlier. And there is the rough position of NGC 752. And we'll switch to our more detailed chart, where you can see it clearly colorized and labeled here. And so perhaps one of the reasons why NGC 752 has been overlooked by mainly me and many other amateur astronomers, because, you know, nearby there's, you know, M31, the Great Andromeda Galaxy, which we did last month, and M33, which is what we're going to conclude with tonight. So there's two big famous objects in this part of the sky, and so poor little 752 here has been overlooked. And so it's located, you know, it's pretty easy to find. It's located 4.5 degrees southwest of Gamma Andromedae, or Almach, right here. So 4.5 degrees to the southwest. And again, its apparent diameter is 1.5 times the full moon. So it's pretty big. So let's switch back to the browser here. We'll go back up, see how we're doing. And we're already, it's already slewed to our target. There we go. Oh, that's probably why the first image suffered a little bit. I should have turned that off. It is nice to have that on, but yeah, ugh. So that infrared light could have caused some issues with the first image. So we're going to turn that off. So that thing is so bright. And let's update this image. I hate it when it does that. Now it's not. Now it's being difficult. There we go. We'll do a hard reload. There we go. Now you can see it looks a little darker in there because I turned the infrared camera off, or light off, on the false cam. And now you can see we're looking pretty high in the eastern sky there. Alrighty. Switch back to the proper window here. And looks like the scene is stabilized a little bit. It's not quite as choppy as it was before. And you can see we're only going to do a 5-minute exposure this time. All right, so that's where we're at. I'll listen for the ding in my headphone here, and as soon as I hear that ding, I know that we're done with our image. And yes, Ted, you are correct. Caldwell is Moore's mother's name, his middle name. But I thought I was pretty sure he had a hyphenated name they just never used. I'll have to go back and read that in the book. Any other questions or comments out there? Give poor Richard's throat a break.
What do you use for your for the sky maps? It looks like Sky Atlas, maybe.
I use Sky and Telescope's Pocket Sky Atlas that I scan and clean up. One of these days I need to buy another copy and just tear apart my current version and just scan the whole thing into my iPad. Well, it's very quiet. So I'm going to switch back to the browser, so at least we have something to look at besides me. I'm no fun. We're almost done there anyway. This will be a short one. And this will be a first, by the way. We've never imaged this before. I've never imaged it at all. So I'll be curious to see what it looks like. Sometimes it's fun to be surprised too. But I usually try to I usually try to check these things out in advance. But like I said, this week I have been incapacitated, which is just terrible. I mean, for the whole time of the pandemic, I wasn't ever sick at all. But the past 4 months, I've been sick 3 times and had double ear infection. So it's been a rough few months for me. I'm falling apart. Whoa, that's a lot of stars. So there's the thumbnail. Stars galore. So what happens, of course, is the data, it downloads from the camera into a program called MaximDL. And MaximDL, it'll do some stretching because the native file is a FITS file. And if you just open a FITS file for the first time, it's like black. So you have to stretch it out. You have to adjust the levels and curves and all that. So it does all that in the background. And sometimes it takes a few minutes or a second or two here. All right, so it's done. All right, so everyone unmute yourself. And here we go. Image number 2. Are we ready?
Ready?
Yeah.
And drum roll.
Sure.
Oh, holy cow.
Nice.
Hey, very nice.
Very nice.
Lines in there.
Yeah.
Damn you, Elon. That's look at all the junk that went through the picture. Oh, that's just terrible.
Is that common to have that many
Oh
items
yeah.
go through?
It's getting more and more common all the time.
Wow.
Yep, there's a lot of junk up there now. A lot of good junk and bad junk. It's hard to tell
Turn
the
off that
difference.
light definitely helped.
It did, yeah. I forgot all about that. Okay, so of course the real challenge of this object is to figure out where the cluster begins. I guess you can see it begins pretty much in the center, and then it probably kind of fades off around here, so I'm guessing. The rest of this is just Milky Way stuff. So yeah, the cluster really gets lost in the Milky Way. I could have probably even done a little shorter exposure to help bring out the cluster more and the Milky Way less. So the cluster is scattered northeast of the bright pair 56 Andromedae, which I'm very certain is these two stars here. This is probably 56 Andromedae here. So this direction would be northeast for reference. And it is a very large, loose collection of 60 to 70 stars, full of short chains, irregular clumps, and a large number of double stars. And the Caldwell objects, a book written by Stephen James O'Meara about the Caldwell catalog, he says the eastern group of stars spells out the word yes. So maybe when you download the high resolution version of this image later and examine it, maybe you can find a group of stars that spell the word yes. You probably have to really spend your time and imagination doing that. But it's supposed to be spelled out in kind of a sprawling, erratic manner. So it's not quite as straight and narrow as you might think. So the chief characteristic of this cluster is that it is old. Normally open clusters like this, they only last maybe upwards of 500 million years, because with globular clusters, which we'll look at one later, they're made of thousands of stars, and so they have a lot of gravitational oomph to keep the clusters together for that amount of time, billions of years. But with open clusters, they're more sparse and spread out. And as the cluster orbits the galaxy, they encounter, dust clouds, external stars, maybe even other clusters, and they lose their members over time. Some of the really young stars maybe just die off, but the older stars, they get kicked out of the cluster. So, and to have one last 1.1 billion years, that tells us that this cluster is kind of out of the galactic plane a bit, so it doesn't encounter too many objects. It's not the oldest open cluster known. That's got to be possibly M67, which is nearly 4.5 billion years old, roughly the age of the sun, but a little bit younger, actually. And we know that through studies, most of the stars in this cluster are in the post-helium core flash phase. So, when stars like the sun, or really any star, they lose all the hydrogen in their core. They consume all the hydrogen in their core, and they're just made of pure helium. So for a long time, the helium core doesn't do anything. It's kind of inert. But gradually, through pressure, because the core is trying to crush itself, it gets hotter and hotter and hotter. But when it reaches a core temperature of 100 million Kelvin, it goes through something called the helium flash, where it generates as much energy as an entire galaxy, and then begins helium fusion. So many of these stars have done the helium flash and are now in the helium fusion phase, which means they're red giants and stuff like that. And this is an open cluster, but it does have a somewhat low metal content that suggests it did form in the outer reaches in the Milky Way. So that explains why it's lasted so long. Because it formed pretty far out, but now it's only about 1,500 light years away. And if you have time to examine it, there's probably just too many stars to see, but there should be definitely 2 galaxies in here, NGC 753 and NGC 708. But upon quick inspection here, I don't see any. It's not obvious anyway. So when you do get this image later, you can try to find at least 2 galaxies in here. They're somewhere near the edge, but I don't see any obvious galaxies. You really probably got to zoom in to see them because they are small. But there we go. I thought that was worth our time. NGC 752, which I will call the Andromeda cluster because it's in the constellation Andromeda. Makes sense to me. All right, so let me scroll down here. I'm going to enter in the designation of our last target with the Takahashi. We're going to go back to 10 minutes and select H alpha there, and off we go. Just do that while we're here. All right, so our last target with the Takahashi is NGC 1499, the California Nebula. So we've done the North American Nebula that looks like North America. So now we'll just do the California Nebula, which looks like the state of California. And again, in the sketch here, done by some amateur astronomer I couldn't give credit to because they didn't give out their name online, you can see it's inverted again because, of course, it should go the other way. So the California Nebula was discovered by E. Barnard, one of the last great visual observers and kind of one of the first great astrophotographers in 1884. And the nebula is pretty long. It's about 2.5 degrees long, or roughly 43 light years, given its distance of 1,000 light years. And that makes its surface brightness very low. And so this is a difficult object to observe visually. I've never seen it visually, but that's one of the great things about these online viewing sessions is we can observe things that are difficult to see visually. And so by coincidence, it transits the zenith in central California at the latitude matches the declination of the object. So at a latitude of 36 degrees, it reaches the zenith, you know, the point directly overhead. And so NGC 1499, the California Nebula, is located in the constellation Perseus, the hero. So Perseus always looks like a wishbone. And Algol is the very famous eclipsing binary. But the California Nebula is on the other side. And if we kind of follow the curve here of this side of the wishbone, that takes us to the Pleiades cluster here. We haven't looked at the Pleiades yet this season, but we'll probably do that probably next month. And again, here's Cassiopeia. That looks like a letter W, which we mentioned earlier. And NGC 752 from just a second ago, that's right around here. So there's the Triangulum constellation, and this is the ends of Andromeda here. So that gives you an idea of what part of the sky that we're looking at. But now here's the close-up image from Sky and Telescope's Pocket Sky Atlas that I just sort of scanned and used there. And you can see it's located 1 degree north of Xi Persei, or the star known as Menkib. Let's see how we're doing. All right, so we've already slewed to the target and acquired a guide star. We can see what the telescope is doing. I don't want to turn the infrared camera on, so let's try this one. Whoops. Oh. I did the wrong command. Oh, I hate it when it does that. I don't know why it does that. Well, now I can't get the thing to reload, but it should be in a different position. We're not looking. It just doesn't want to reload. It's being so difficult. There we go. 8th time is the charm. So there we go. We're not looking quite as high as we were before. That's a roughly live view of the telescope. Let's check what the, let's see what the all-sky camera looks like. You can see Orion is clear on the horizon. At just the right time, we'll get to see the summer triangle, the great square, and the winter hexagon all at once, but we're not quite there yet. See what, oops, here we go. I don't know how updated this is. There we go, that looks pretty good. Yeah, the time's different. So you can't even see Orion here yet because his dome blocks it. But we can see the Pleiades. So this is Perseus right here. And we're imaging right where this little red squiggle is. That's the California Nebula right there. You can see it in this image. So, of course, we'll get a little bit closer to it, but we'll be roughly looking at this patch of sky right about here. So it's a pretty wide field of view. And there we go. We're doing a 10-minute exposure because in H alpha, this thing looks pretty sweet. And again, we have time for questions about the telescope or target or anything. Okay, I'm back. I had to clear stuff out of my body again. Ugh, terrible. What brand of filters do we use? We use
Astrodon.
Astrodon. That's it. I couldn't come up with the name. Thanks, Pete. I need someone to bail me out tonight. My brain is not fully recovered yet, but yes, we use Astrodon filters, the 50 millimeter square version. When we first bought them, the narrowband filters were, I think, $1,200 a pop. They're not cheap. Aha! You are quite right.
Here's some good news about Hubble.
What's that, Dave?
Oh, I heard they got Hubble back online today. It was
I-
offline because of one of the gyros.
Oh, I didn't know it was offline.
Yeah, for a couple weeks.
Huh. Nope, you can see I haven't been keeping up. Well, thank goodness our telescope is working. That's all I can say. Yeah, let's go back.
And it's clear skies.
Is it clear outside?
Not here.
Oh, I didn't think so.
Oh,
I didn't think so. Yeah, we're about halfway in there. Let me reconnect to the computer out west and we'll do a weather update. Because it won't stay connected the entire time anymore because they've limited the non-licensed version, the cheapskates. So the wind is still really good. I thought the wind might be an issue tonight. because it said it could have been upwards of 10 miles per hour, but it's still a fairly steady 3.2, 0.3 miles per hour. And now the humidity is only 19%. I wish I could go out there. I'd probably dry out in a hurry. And the temperature is 42.3, which is what, pretty comparable to what it is here, right? Probably not right now, but that's about what it was during the day today. But I can't tell you for sure because I haven't been outside in days because I've been so sick.
42.9, at least down here.
Is that what it is right now?
Yeah.
Wow. Okay. So the temperatures are really comparable. That's amazing. Well, what's the humidity here right now? I bet it's awful.
76%.
Oh, that's awful.
Hey, that's dry for here.
Yeah. And of course, over on the right, you can see ACP. You can see my name here because I'm connected to it via the web browser. So ACP is a program that controls programs. So ACP is running Maxim here. So this is Maxim DL. You can see the guide star that the program has automatically selected. And again, this is Clarity, which is our weather program. And this is M1 Oasis, which controls the roof of the observatory. And I have the window, oops, well, maybe I can't look at it. There we go. I don't know why it's yelling at me. But here's the window for Focus Max. This is what we focus with. I always try to focus before the session. I never focus during the session, although you can see the sharp curve here. This is the Takahashi focus, which goes very fast. Initially, the plane wave focuser is really slow because it takes forever to home itself. But once it's homed, it focuses pretty quickly. But I don't want to focus during the session. But it wouldn't take too long if I had to do it again. So we're almost done there. Let's go back to the browser. And you can, and again, I'm doing the acquire a single image routine here. We can open up the color series. And you can see that if I wanted to, I could use different filters with a variety of exposures. In fact, this is what I was working on recently with another target, M33. I might try to acquire some more images tonight, but I was doing red, green, blue, not H alpha. I haven't done much in the way of H alpha yet. So if you want to do a whole bunch of images through the entire night, you can, but what I'm using during the session is just a single image one. And down here, you can see we have a bunch of custom scripts. This is the startup for the 20-inch, startup for the Takahashi. If we want to close up, I hit that one, which I don't want to hit. Then we can switch telescopes mid-stride here too. So as soon as we finish up with the Takahashi, I will select this script here to switch from the Takahashi to the big scope, the plane wave. And there's all kinds of other scripts that it comes with. All right, looks like we finished the exposure. So we should see the thumbnail pop up there pretty quick. But then again, it will take about a minute to process the bigger view. Ooh, pretty. So that looks much better now that I got the hydrogen or the infrared light off. Hydrogen light. There could be some hydrogen in there too. Let's see. There's 10,126 stars that were found in the image. Well, that's a lot. It used to crank out the final image pretty quick, but it's been getting slower over the years here. Be hot back there. It's still working. All right, so get ready. It's building the anticipation. Oh, there we go. Now it's ready. All right, everyone unmute yourself. Here we go for the big unveil. The last image from the Takahashi. Looks pretty good.
Yeah.
Still a little on the faint side.
Hmm.
But don't
Right.
worry, I will
Yeah.
process it so it's a lot brighter.
That's beautiful.
But the thing I love about this one is with hydrogen alpha, you got those great just billowing clouds. Isn't that beautiful?
Very nice.
Very nice.
Yeah.
Yep.
So this object is drifting through the Orion arm of the Milky Way. And it's probably illuminated by Xi Persei, which is a hot blue-white giant star of spectral type O7.53, which means it's a really big O type giant star, which is not in the field of view, by the way. And the Perseus OB2 Association, of which Xi Persei is a member, probably arose from this interstellar cloud. So the OB2 Association, it's like a cluster of stars, but it's not bound by gravity. So I mentioned how cluster stars, tend to break apart over the course of 500 million years. So associations of stars, they just kind of move in the same general direction in the sky, but they're not bound by gravity. So they only last maybe 1 to 2 or 3 million years. They drift apart much, much faster. But of course, this is a interesting region of star formation, which just so happens to look like the state of California. And again, you'll be able to download the full resolution version of this later. It'll be a little better processed than Maxim does on the quick job there. So it'll look a little brighter, a little sharper than what you see here. So there we go, our last target with the Takahashi. All right, so now we're going to use that one script I talked about. We're going to, in fact, first, before I forget, because I'm thinking of it right now, I'm going to go into ACP. Here, I'll show you what I'm doing here. I'm going to go into the settings for ACP and change the focal length of the telescope and aperture, because I always forget, because it's currently set up for the Takahashi and not the plane wave. But now that we're going to switch to the plane wave, I need to switch that, otherwise it won't point terribly well. I mean, it still does a pretty good job, but it won't be perfect. All right, now I'm going to go back to the browser and go ahead and switch it up here. All right, so it's going to close up the Takahashi. And while that's working, let me introduce you to our next telescope. So yes, we are going to close up the Takahashi here and switch to the big scope, the Planewave CDK20. So, someone had a basic question about telescopes. So again, the Takahashi has lenses up front here. Well, this telescope has 2 mirrors. It has a kind of ellipsoidal, kind of a curved primary mirror in the back that is 20 inches across. And you can't see the secondary because, here it's daytime and we try to keep that covered up during the day. It has a spherical secondary mirror up front. So the light goes in, reflects off the primary, up to the secondary, through this opening here into the camera. And so again, it's a 20-inch corrected dull Kirkham, which means there's like a little lens group in the back that does the correcting. That's where the C part comes from. And yeah, it does weigh a staggering 140 pounds. But it's greatly supported by our main mount there, which we'll introduce you to shortly. But here's the business end of the 20-inch. It uses the same exact model camera as the Takahashi, which has caused some problems over the years. Having two identical cameras run off the same system probably was not the best move ever, but nobody ever said anything. So I'm not the only dumb one that did that. And then we have the same filter wheel that we've never had issues with, like with the Takahashi, where it comes loose every so often. And then we have something called an on-axis guider, which takes forever to explain. And then we have an auto guider. So I mentioned we acquired guide stars, and they are acquired with this little camera here. And then you can't see the whole thing in the picture here, but this little black box on the end here is the focuser I mentioned earlier that takes forever the first time. It's really loud too. If you're in the observatory, you know when that thing's running because it is loud. And all this is supported by the great software bisque Paramount ME2, which is a German equatorial mount. You know, the telescope goes on this end here, of course. This is when we were first putting it in. And there are several counterweights here, more than you see in the picture here. It holds 240 pounds. With the plane wave and the Takahashi, that's probably around 200-ish pounds, probably not quite that much. So we're nowhere near tapping the potential of this mount, which is good. And it holds 480 pounds total with the counterweights. And we got quite a few on there. And it's very, very accurate. All right. So let's go back to the browser. I think we're all good there. Yep, we have successfully switched telescopes. Yep. And we're going to enter in the designation of our first target, which is M2. Hit get coordinates, which it does. And this is a pretty bright target, so let's just do, shall we do 2 or 3 minutes? 2 or 3 minutes. Let's
3.
Sure. Yeah, let's go ahead and do 3. I couldn't decide. It's bright. I don't want to burn the core out, but let's do 3. All right, there we go. So here we go. Our first target with the plane wave is M2, which I will call the Aquarius cluster because it's the most dominant cluster in Aquarius. Again, most everyone just calls it M2, but why not call it the Aquarius cluster? This was discovered by the Italian-French astronomer Giovanni or Jean-Dominique. When he moved to France, he changed his name from Giovanni to Jean-Dominique Domenico Maraldi. September 11th, 1746. And Charles Messier added it to his catalog September 11th, 1760, like 14 years later. And he described it as a nebula without stars. Boy, was he wrong. But of course, Charles Messier, he mainly used small refractors. So that's why this is part of the Messier catalog, because at the low powers he was working at, it looked very comet-like. And if you don't know, the Messier catalog is basically a catalog of objects that look like comets to Messier. Not all of them do, but that's a whole other different thing. And William Herschel observed it with his 4.2-inch sweeper telescope in 1783 and wrote that it looked like a telescopic comet. So he thought it looked very comet-like as well. And then in 1794, using the 6-inch telescope, Herschel saw a cluster of stars, many of them visible. So finally, someone saw it for what it was. And then John Herschel, the son of William Herschel, using a 9-inch telescope in 1830, described it as a heap of fine sand, which I guess is a pretty apt description. And so here is its rough position in the sky. I did not mention Aquarius. That's kind of a hard constellation to pick out on the all-sky camera. But here's Enif, which is the nose of Pegasus, the winged horse. I mentioned that earlier. And I could have pointed out Capricornus, but I didn't do that. Capricornus is pretty easy to see on the all-sky camera. And there's Altair, the tip of the summer triangle. So it gives you a rough idea where M2 is. But here's the more detailed view with the pocket sky atlas. And we did look at an open cluster earlier, but again, this is a globular cluster. Open clusters, like NGC 752 from earlier, they're confined to the disk of the galaxy, while globular clusters are located in the galactic halo, which is above and below the plane of the galaxy. And so they orbit around the center of the galaxy in very long elliptical orbits that take hundreds of millions of years, but so does the sun. So M2 is not in the galaxy itself, but it's in the halo, kind of a cloud of stars around the galaxy. But globular clusters are the most obvious part of the halo. And so in my headpiece here, I can hear it looking for a guide star, which it looks like it has done, but it's not quite there yet. But no, now we're waiting. And it should guide here pretty quick. And again, we're only going to do a 3-minute exposure, so this time it'll go pretty fast. All right, we got time to check in with anybody. If anyone has any comments or questions or anything, give the old throat a minute to get a break there. If anybody wants to bail me out. At the start of the session, this thing was full. Now it's like down to here. I'm in trouble. When that runs out, I think the session might have to be over. All right, well, let's go back to the browser. Let's see. That's where the telescope was. Now let's see if I can get it to update again. Oops. That's not what I wanted to do. Well, it's being difficult. I'm not sure what I'm doing wrong. Oh, I know what I'm doing wrong. That looks better. So now it's pointing in the opposite direction, and you can see the flip flap of the Takahashi is closed. Proof that we are now using the plane wave. Oh, I logged out of the pause cam by accident. I don't want to turn that back on though, but you can see we have way too many lights in the observatory there. We need to clamp that down. It's getting out of hand. It's really getting really bright in there.
Is the neighbor out of hand?
No, he's being good. Look, you can see his house lights on now. So if he wasn't home before, he's home now, but at least it's not really obnoxious. And you can see now Orion has totally risen. And you can see there's a little bit of sky glow there. That's why we're not a Bortle 1 site. We're kind of a Bortle 2 on the light pollution scale there, but it is mighty dark there, trust me. Let's see. There's David's view. We're getting some, I don't know, bandy in there. Maybe some thin clouds, or almost like looks like gravity waves. That's interesting. Or maybe it's just dust. It's probably just dust. That's probably what it is. And oh, we're already done with our exposure. You can see for some reason it always goes like several seconds past, but it doesn't actually do that in maximum. Oh, there it is. I don't know. I think maybe we should have done 2 minutes. It looks a little burnt out in the center. That image is processing in the background. Now it's only found 4,633 stars. I guess it doesn't count the globular clusters stars. That would like break the counter. Yeah, there we go. Now it's done. All right. Are we ready? Here we go. Ta-da!
Nice.
Ain't that cool?
Cool.
Very nice.
Good stuff.
Nice corrected field.
Yeah. So this is cataloged as a class 2 globular cluster due to its dense compact core, but compared to M15, that's nothing. M15 has a very dense core. It is one of the largest and richest known globular clusters. It's 175,000 or 175 light years in diameter, with a population of at least 100,000 to 150,000 stars. The brightest members are red and yellow giants, and it does have an age of approximately 13 billion years old. It's one of the older globulars associated with the Milky Way galaxy. And it has a possible dust lane along the northeast quadrant, which I don't quite see here. Sometimes you can see it, but that might require closer examination later. Sometimes it is evident in this cluster. And it's part of what's known as the Gaia sausage, the hypothesized remains of a merged dwarf galaxy, along with 7 other globular clusters. So this may be the nucleus of a now devoured galaxy by the Milky Way. That could be the case for several globular clusters, like, for example, Omega Centauri, because it's so big. But there we go. There's M2, the Aquarius cluster. Very cool. And by the way, I need to look at my records more closely. I know we've done this before, but looking at the records of what we've done during past online viewing sessions is I couldn't find the time that we did this. So this could be our first time doing this during an online viewing session. We may have done this during the first season that we did live or in person at Western Michigan University, but we decided to switch online because it works a lot better, I think.
Richard, we did it on November 14th, 2020.
Okay. Huh. I have to go back and look at my records. I'm glad Becky keeps better records than I do. Or again, I've been so sick, I just can't see anything.
I'm just a squirrel, Richard.
Yeah. All right. Now, this is definitely a new target, NGC 7380. And I'm pretty sure I want to do 10 minutes of this thing at H alpha. So off we go. I did get coordinates, right? Okay, I think I did. All right. Yes, so our next target is NGC 7380, the Wizard Nebula. So the Wizard Nebula is an emission nebula that surrounds the open star cluster NGC 7380. So 7380 is actually the designation for the open cluster, not the nebula. But because this object is so popular with imagers, people often tend to ascribe in the NGC designation to the nebula when it does belong to the cluster. So the nebula itself, though, is cataloged as Sharpless 2-142 in the 1959 Sharpless catalog. It was discovered by Caroline Herschel on August 7th, 1787, on the occasion of being free from recording duties when her brother William was absent. I believe he was in the process at that time of getting married. And it was actually observed by William Herschel on November 1st, 1788, several months later. And he described it as a cluster of coarse, scattered stars, 8 arc-minute diameter. So he did not note the nebulosity. And here's its rough position in the constellation Cepheus. So Cepheus is this constellation that looks like a house. And in one corner, there's this little triangle, which almost points right at the Wizard Nebula. And we switch to the pocket sky atlas, and we see where 7380 is here. And you can see Cepheus is a very, very busy constellation. We've done this area before. This is where the Elephant Trunk Nebula is. We've never done this before. We should do this one time. This looks interesting. And then one time with the 20-inch, we need to try the Bubble Nebula. I've never done that before either, during a session or imaging on my own either. So there's lots of nebulosity in this region, and the Wizard Nebula is one of the highlights. So it's located about 2.5 degrees east of Delta Cephei, which is a very well-known variable star, but also a very nice double star too, right at the tip of the triangle there. That's Delta Cephei. And it is extremely difficult to observe visually, at least the nebula is, and it requires very dark skies. I have read of observations with no filter, but it's best to use either maybe a UHC, a narrow band, ultra high contrast filter, or an oxygen 3 filter. But under the dark desert skies of Arizona, and with our very sensitive camera and big telescope, it should look pretty good. All right, so again, in the background there, I've heard some dings and whistles. So we have already acquired our guide star. Let's see what the telescope is doing now. Let me try to do this correctly this time. Get a refreshed view from the camera. Let's see, there we go. So yep, that makes sense. We're looking up towards Cepheus, which is in the north. So this wall here is facing north. And the infrared light from the PEC cam isn't so bad. It shouldn't cause too many problems here. But when I do image more seriously, I just turn this thing off. I even disable it in the computer, so I know it's definitely not on. Right. And there's all those internal. Oh, look at that. There's that pesky neighbor. His light in the house is too bright. This guy needs to get like a curtain there. Tell him, Mike, curtain, curtain. Hopefully Mike Patton is still listening. And even though it's a pretty nice clear night, David Churchill is not using either one of his telescopes. The domes are closed. Let's see if I can pick out Cepheus. I think it might be behind one of the domes.
Which focuser does the plane wave? Does it use an actual plane wave focuser?
No, it uses I'd have to go back. I'm blanking on the name again.
Is it the Hendrick focuser?
Let me
Or Kendrick? I don't know.
no, here I'll tell you.
Asking the tough questions.
I know. It's a Finger Lakes Atlas
Oh,
focuser.
okay.
There we go. I have no idea what screen I'm sharing, so I'm just gonna stop sharing the screen.
Hey, Richard, how did they get away with designating the same number for both a nebula and a cluster?
Well, they don't. It's just because the nebula has become such a popular target for imagers, they just associate it with the NGC designation, like I mentioned earlier. But the nebula itself is really part of the Sharpless catalog.
Okay.
And I tried to find out who actually discovered the nebulosity and who named it the Wizard Nebula, but you know that stuff just gets lost. I have no idea who actually discovered the nebula and who named it the Wizard Nebula.
Okay.
What's a good like freeware planetarium program these days? I'm still using the Sky 6, which ancient.
For freeware, you can't beat Stellarium.
Stellarium.
Yeah, Stellarium's great. It has lots of add-ons too. So yeah, so if you don't want to buy something like the Sky or Starry Night, you can download Stellarium.
Yeah, I just want something just to like for framing and a little better UI. I'm not looking to do anything crazy.
Yeah, Stellarium can do all that. It's all add-ons. It doesn't. You can't download everything at once. You got to add stuff on. But yeah, it's Stellarium. If I had it handy, I'd put the link in the chat, but I don't have it handy. So someone can bail me out there. And
I'm Googling right now.
oops,
Oh, there it is.
I've lost track of where I am. Okay, let's
There
see.
it is. I dropped the link in there.
Sweet. The browser. Where's the browser? Oh, there it is. Oh, look. Speak of the devil, David has just opened his dome.
He heard you. He must have been on the call.
Yeah. He's like, well, fine. I'm just going to use my telescope then. And you can see Orion is now clearing his dome.
How low can the remote telescope image?
I think we have it set to where it won't go below like 10 degrees or so, maybe even 20.
Oh, so still pretty low.
Yeah, I think 20 might be the limit, but I can change that because I've been meaning to try to see if I could bag Omega Centauri, but it'd be tough from the observatory.
How much farther south is like the Texas Star Party? I know we can image it from there.
Yeah, I think they're another few degrees south latitude from what we are here. Not much though.
Yeah. You ever gotten the Thor's helmet? That's fairly low.
Yes, we can do that. I was going to try to do that maybe next month or February.
Oh, that'd be cool.
We've never done that during a session before either. So yeah, that'll be a target for either January or February. I've been meaning to do that one for a while.
Is that a Takahashi size or a?
No, that's a plane wave target.
Oh, okay.
I know Lloyd Simmons was working on that, but then he stopped for a long time. But he signed up to use the remote telescope again, so maybe he'll take it up again, or at least I will. But I've started so many projects, I need to finish some up.
Hmm.
I'm
Is
bad.
that a like a good narrow band or is it a broadband more?
Yeah,
Or both?
I think he was working on a narrowband version,
Hmm.
but I think that can go either way. But
Yeah,
probably better with narrowband.
yeah, I've never tried it, and being winter,
Yeah,
I'll be lucky if I can get the horse head done.
yeah. We'll probably do the horse head either next month or February too. That's when we try to do at least once a season. It's a crowd favorite. Got to do the horsey.
Yep, horsey. Hey, I
That
haven't
one,
missed a remote viewing session, so I'm on a roll. Keep me coming.
you guys have done the horse head since the early hard times at the beginning.
I know I think we did it last season, which was very short because the weather was so rotten and we had equipment issues, but the equipment issues were never a factor because of the weather. Because they
Right.
had that's because last winter is when California was getting all that rain, but in Arizona they were getting the cloud part of it. So it was unusually cloudy out there last winter. So far, it's been a very regular season this year. Just a
Cool.
little glitch with the Takahashi last month.
All right.
Otherwise, it's been fine. The only glitch this month is with me and my messed up throat.
Is it from the whole speaking tour, you think?
I don't know. I don't think so. I haven't done very much yet. In March, I will. Well, we're getting there. All right. While we're finishing up here, I'm going to mute my camera and stuff. And okay, I'm back. Oh boy, this has been a rough week. All right. Well, we're done. Hooray! Let's see. Again, this is a new target. I don't know quite what to expect. It should look pretty good in H alpha. Ooh, that looks promising.
The billowing clouds.
Yeah, billowing. And 3,520 stars found. Let's count them. 1, 2, 3.
This was H alpha.
Yep. Now, somebody, another remote telescope user, did do some luminance images that I did peek at earlier today. And boy, in luminance, the stars really blow it out because they're so bright. So it should look better in H alpha. There we go. All right, are we ready? Unmute your microphones. Here we go. We gotta scroll down. It doesn't look quite as good in the regular view here, but still, that's pretty cool.
That is pretty sweet.
Yeah, that's cool.
That's really close up.
That
Usually,
was 10 minutes.
yeah, that's 10 minutes.
Gives kind of a neat 3D look.
Yep. We sometimes have issues, again, with the north wall with all the illumination we have in the observatory. So we really need to clamp down on that. Next time I go out there, I'm going to have a big tape of red cellophane and just cover the entire wall up with red cellophane, I think. But still, when I process this, it should come out a lot better. Maybe Maxim isn't doing the best processing on some of these either. It could be that too. Because I think I thought the same thing with some of the targets last month, but when I actually process them, they look better. Okay, so but the
So
cluster
which
really,
are the, oh,
yeah. No,
Yeah.
go ahead. Go,
yeah, my question was, where are the stars in the cluster? And you were about to tell us, so.
yeah, so I imagine pretty much all around the nebulosity itself is the cluster.
Okay.
So maybe one year we should do this with the Takahashi too, just to get a sense of the get a sense of the lay of the land. But pretty much the cluster and the nebula should be associated with one another. But the cluster, and this may be an error from what I read today, but because some of it didn't make sense, but because I read the cluster has a radius of about 100 light years, and it contains roughly 125 irregularly scattered stars. And the cluster's brightest star, and I can't tell you which one it is the eclipsing binary DHC5, which is an O5.5 star. So, amongst the hottest type of stars. And it's that star, which, again, I don't know which one it is that's responsible for clearing the surrounding dust and gas, and may triggered a lot of the star formation that we see happening in the Wizard Nebula. And DHC5 is also the main star that illuminates the nebula. It excites the gases and makes them glow. So the cluster has an age between 4 to 12 million years old. So compared to the cluster we saw earlier, NGC 752, this thing is extremely young. It's obvious because the cluster is still in the nebula. So they haven't even separated yet, or the nebula hasn't dissipated, because the nebula will probably dissipate in about 2 more million years or so. And the physical size of the nebula is maybe about 6 parsecs, or about roughly 20 light years. And again, it's about 8,500 light years away, and it's in the Perseus arm of the Milky Way. So there we go. The first time, at least the remote telescope has ever done this in hydrogen alpha. And again, the processed view should look much, much better. And it looks pretty good there. There's some nice detail there. But we'll get rid of a lot of the noise and brighten it up a bit too when I do the processing. Okay, our very last target for the night, if you were paying attention earlier, is M33. We'll do 5 minutes with the luminance filter. And this should look pretty good. That's why we're saving that one for last. But plus we're kind of working eastward too. All right, so M33 is known as the Triangulum Galaxy because it is the dominant galaxy in the constellation Triangulum, but that's a very common name. That's not one that I made up this time, like the Aquarius cluster, because no one really calls it that. And it's often referred to as the Pinwheel Galaxy, but that name is generally given to M101 in Ursa Major. It was probably discovered by the Italian astronomer Giovanni Battista Hodierna, who we mentioned earlier, before 1654. And he noted a cloud-like feature near the triangle. So it was probably this. And it was independently discovered by Charles Messier on the night of August 25th, 1764. And among the first spiral nebulae identified as such by Lord Rosse, William Parsons, in 1850. He's a very famous observer who used the Leviathan of Parsonstown, big 60-inch Newtonian reflector in Ireland. And so, as noted, it is in the constellation Triangulum, but it's closer to the border of Andromeda, but technically it's across the border in Triangulum, as we'll see here shortly. So here's its rough position in the sky, right near the triangle. And here's the Great Square. The cluster that we looked at in Andromeda is up here. So we're right nearby. What we did with the Takahashi, now we're doing with the plane wave here. And this is the same chart that we had earlier when we looked at 752, but now we're down here looking at M33, which, as you can see, is just across the border, really from Pisces in Triangulum. So the border for Andromeda is like way up here, but you know, who cares about constellation borders? So it's 4 degrees west-northwest of the 3.4 magnitude Alpha Trianguli, right at the tip of the triangle there. And M33 and M31 lie on opposite sides of and nearly equal angular distance from Beta Andromedae, or Muroc. So they're pretty much the same distance from here to here, from here to here. Andromeda, of course, is an easy binocular target. M33 is easy under dark skies, but it can be a little challenging, at least around Michigan, at least around, you know, Kalamazoo. But under dark skies, I've only seen M33 naked eye once. And that was at a friend's former bed and breakfast between Flagstaff and the Grand Canyon, who Pete knows as well, or at least knew. But now he sold that, and apparently he lives in Alaska. Why, I don't know, but whatever. All right. I can hear the browser working in the background there. We've just acquired our guide star because of course, the telescope had some slewing to do because we were looking toward the north. Now we're looking toward the south, and it just popped up a little thumbnail of the guide star. And now we've begun our exposure, so we are underway. Let's see if we can get an updated view of the telescope. That was probably it. I don't know why it does that. Come on. Sometimes the hard reload doesn't work the way it's supposed to work. It's supposed to definitely do it. There we go. Yeah, perfect. And you can see there's a bright reflection because there's a reflector here. When the telescope is in the park position, it triggers a sensor, so the system knows it's safe to roll the roof back on.
And that is not park position, is it?
No, this is not the park position. Although with the way the roof is, it'd probably be okay this way. But of course, we wouldn't want to slew the telescope. So boy, this thing's almost right at the zenith. So this should look pretty good.
Is that scope on a dovetail? I mean, a saddle? Or is it bolted right? Oh,
No,
okay.
no, it's on a dovetail.
Wow.
Yeah. Let's check the all sky camera. Oh, that pesky light's on. Oh, we're gonna have to get them.
I'm gonna start flying my drone there.
You know, dude, you know, gotta talk to this guy. Like, dude, we have curtains. We have that technology. You know, buy a curtain.
Wasn't that this is about as bright as the red was, wasn't it?
Not quite as annoying, I don't think, though, because the red light was like pointed like right at us. This guy does not get the sense of a dark sky village.
Yep.
You can email him a
Downgraded to
picture,
Bortle.
can't you?
I sent Mike pictures of the red light. I don't know if Mike ever shared them with him.
Bortle 5 now.
Yeah, we're down the Bortle 5 because of this neighbor. That's harsh. Oh look, Mr. Churchill has turned his dome.
His light's on, the red light.
Oh
on the
yeah,
other-
yeah, he has the red light on inside. Maybe he's actually there working. Huh.
You'll see a ghostly figure on there.
Big creepy guy walking across. And let's see, we were looking. Well, here we go. We're looking right about here, I think.
Yeah.
Here's Triangulum. And there's Murrock. So we're looking like right about there.
Yeah, you can see Andromeda.
You can see Andromeda, but you can't see M33. At least I can't tell if I can see it. It could be one of these smudges, but I can't tell.
Camera looks out of focus.
Yeah. Well, the stars are a little trailed too. He talked about that a little bit when I chatted with him. Okay. We're trucking along here. I'll just go ahead and keep ACP up. But again, if anyone has any questions or comments, please chime in. It's supposed to be an interactive session. Letting poor Richard's throat get a break. I need a throat lozenge, but I got to open a new bag. Plus, I'm sure that doesn't sound very good on the microphone. Me sucking on a lozenge. I'm sure that wasn't fun earlier.
Well, I can chew on some celery if that would help. Sorry, I got in really late, Richard.
Oh, that's no problem.
Been a whirlwind tour tonight.
Mm.
Lots of stuff going on.
All right, I'm going to mute again. I'm about ready to hack up along. Hang on.
There we go. Somebody wrote in that there is a occultation of Beetlejuice.
Yeah, way down in Florida.
Oh, okay. Is that the asteroid doing? That's the asteroid doing that. Okay.
Yeah.
Yeah.
Could be Planet X. I don't know.
Well, I'm sure someone will look up and think that Betelgeuse went supernova and is dark.
Yeah, for a split second. Oh, Beetlejuice blew up. Oh, wait. Oh, it's back. It's fine.
Yeah.
Oh,
Well,
there we go.
the last occultation with this asteroid, they were able at least to determine that it's oblong versus spherical. So
Cool.
cool science.
Yeah, I'll have to look for some video of that where Beetlejuice just suddenly goes.
Ooh, look at that thumbnail.
Yep, looks pretty good. Hopefully the bigger picture looks better.
Have you ever shot a H alpha of this? That'd be pretty cool.
I have, yeah.
It's just like splattered with H alpha.
You talking about M33?
Yep. Oh, M33 has tons of nebulosity.
Oh.
All right. How many stars did it count? 9,750. All right, are we ready for our last target of the night?
Yeah.
Here we go.
Ooh.
Oh, that's cool.
Ooh.
Really gotta go up and down to see the whole thing.
Yeah.
Hi, neighbor.
Yep.
Cool.
All right, so the Triangulum Galaxy is often thought of being face-on, but it's actually inclined at 54 degrees. So kind of a semi-face-on spiral galaxy. It's 60,000 light years in diameter, you know, from roughly up toward here, down toward here. And it contains 40 billion stars, like 10% that of the Milky Way. It is the third largest member of the local group after Andromeda and the Milky Way. And again, it's roughly 60% in the Milky Way size. It's currently moving toward M31, suggesting it is in fact a satellite galaxy of M31, but that's still far from proven. M31 and M33 are less than 300 kiloparsecs distant from each other. And it says in some notes that I looked up, will eventually merge. But remember last month, I played a simulation of the merger of the Milky Way and the Andromeda Galaxy. And I've seen other simulations of that merger, and M33 always survives. So as far as I know, M33 is going to be fine when the merger begins in 3 billion years or so. Now, one interesting little tidbit is this is a pretty good sized galaxy. And usually galaxies this big have supermassive black holes. This one does not. As far as we know, there is no supermassive black hole at the heart of this galaxy, which is really unusual. And M33 does contain NGC 604, one of the largest known emission nebulae, nearly 1,500 light years across. And correct me if I'm wrong. Hang on here. Somebody needs to mute themselves, please.
Everybody else at the same time. I mean, their family, they're not strangers off the street.
Hang on. Okay. There we go. You are muted. Okay. So I believe this is NGC 604 right here.
Yep.
I'm pretty sure. I mean, it's pretty obvious. It's a big patch of nebulosity. So if we did do this in hydrogen alpha, this thing would really, really stand out. Because there is a lot of nebulosity in this galaxy, and this thing is big.
Is this considered?
Yeah, Joe,
Oh,
go ahead.
I was going to say, is this considered a barred spiral or not?
No, it is not.
Because I don't see a bar.
No, yeah, there's no bar.
Just amazing how much the scope has resolved all those stars.
Yeah. Yeah, these little dots. Yeah, these are stars in another galaxy. Isn't that amazing? Looks like
Especially
Orion's belt right there.
The top right arm there, that fainter, that's all resolved.
Yeah.
It's crazy.
All right. There we go.
Were you able to get the Takahashi to work today?
Yes, it worked just fine. Thank you very much.
Okay.
Okay. So let me do some closing thoughts here. Of course, if you join the Kalamazoo Astronomical Society or are already a member and live in one of these counties in red, you are eligible to use the remote telescope for your own private use. Unfortunately, we can't open it up to people across the country or the world because we just don't have the member resources to keep up with the demand we would get from people all across the world. So we just can't do that, unfortunately. But you can always join us for an online viewing session. We have 2 left this season. The next is scheduled for January 6th with a cloud date of January 13th. And let me pop in the chat there. I'm just going to put them all in at once to save me some time here. Here are all the links of what I'm about ready to talk about. So amongst the first is the registration link for the January online viewing session. So if you don't get it off our website, you can get it off the chat there. But of course, if you are not a member, you can join our online viewing session email list. This is for non-members. Members get their own separate email. But if you're part of the email list, you can get reminders about sessions, registration, and YouTube links. I didn't do tonight's session on YouTube because we expanded our Zoom capacity to 500 for our Eclipse series, and there was no reason to really have a YouTube session. It also includes a link to download the session images. And if we do have to cancel or postpone a session, you'll be notified about that as well. So you can email us at this address to be added to the email list, or you can use our contact form. There's a little option to select that you want to be added to the online viewing session email list in one of the pop-up menus. Our next event is on December 15th at 8 o'clock p.m. Alan Dyer will present part 2 how to process eclipse images. Part 1 will be available on Monday, by the way, December 11th, if you missed it. Shame on you for doing so, by the way. And this is part of our eclipse series. And of course, our Introduction to Amateur Astronomy lecture series returns for maybe the last time ever. We don't really know, on January 13th. And of course, I'll be hosting that, and hopefully in much better form than I was tonight with my poor throat. But again, if you attend all 5 sessions live, you can receive a certificate of completion. Just register at the link provided in the chat, or you can find that on our website. And of course, yesterday was December 8th, which means we are now less than 4 months away from the great North American eclipse. So if you have not purchased any eclipse shades, you can purchase from us now. We charge $3 a pair. They include a nice little postcard with information about the eclipse and a little plastic bag to keep your glasses in so they stay safe. And maybe with all the proceeds we get from eclipse shade sales, we might use that to help upgrade parts of the remote telescope, like the cameras or the all-sky camera. So be sure you purchase your eclipse shades from us directly. Don't buy them from some profit company or even a museum. You know, they get, you know, endowments and tax money. We don't get anything, just member dues. So buy them from us. And of course, here is the link to download tonight's images. They won't, of course, don't try the link right now because I got to process the images, but I will have them up there no later than Monday. For the images last month, I had them up later the following morning because I processed them pretty quick. I don't know if I'll process them as fast this time because my throat hurts and I want to go lie down, but I should be fine. But I should get those definitely up no later than Monday afternoon. So with that, thank you everyone for joining us for another great online viewing session. Thanks for being here.